So this is the setup for today. We have here some old conductive papers to use them as draft and try before using a new conductive papers. Conductive papers mean that it conduct and the electrons and charges flow through the paper itself, and it has a specific resistance between each 2 points on it, and it has for sure specific resistivity. This is a new sheet with a corkboard to use it to fix everything. These are two conductive pens. This one is a silver ink, which means it has higher conductivity, lower resistivity. And this one is a nickel conductive pen, which basically it has less conductivity than silver, which means higher resistivity. This is a pen just to mark and draw with it. It is a template. You can use it to draw straight lines or circles. These are some metal push pins, so you fix everything and also connect the lines that we are going to draw, and basically connect them to one of the multimeters. We have two different types of multimeters. You can use any one you would like. We will use today this one. Mainly we'll be using DC voltage and resistance. For the probe that we need, I would say we need this type of probes. For the multimeter, you could use this one. It's basically a alligator clip probe that you can basically put it on the top here. Yeah, you put it like this. So basically this probe becomes not pen like this one, but it becomes like alligator clip. We have two alligators cables. We might need them. And we also have a DC power supply that we could supply some voltage. And we are going to use today 10 volt to supply. And these are the two probes for this power supply. And as usual, we have the lab manual that we use for our lab for today. Hello again. So let's start the lab itself. So this is one of the conductive paper that has been used before, and basically we need to use this basically to not damage the old ones, also the new ones. So let's, for example, like we kind of try to kind of clean the tip of the silver pen and start to have some lines until you have seems to be a consistent line, which is good. Let's try the other one as well, because we prefer to use the silver one, but if it is not available, we will use the nickel one. So right now it seems both of them are good and clean and are able to produce these without no problem, the liquids or the conductive material. So let's do some measurements just to show you. Let's go for the ohms. And let's have some measurements just to show you the conductivity. So if you press these two lines, shows you almost 0 ohms. But if you have here, see how much value the resistance between these 2 points on the conductive sheet is around 34,000 ohms or 33 kilo ohms. And this was a silver line that I have drawn before, and this one's a nickel one. So let's see how much resistance between these 2 points on one line. So you see, it's almost 4 ohms. So you see here, it's high, 40 kilo ohms. However, here, it's around 5 ohms or 4 ohms. However, in the nickel one, it's around 14 ohms. But I have to mention that I had to draw 2 lines of the nickel conductor on the top of one another. Not like this one, which is just one layer. Okay, I had to do 2 layers. One layer, then I waited until it dried. Then I have drawn another layer compared to the silver itself. So you can see here, it's almost 13 ohms, and this one, 1.7 ohm. Okay, so let's start by drawing something on a clean paper. Remember to not draw on the conductive paper while it is on the corkboard. And here we will try first to draw 2 lines using the silver. Hopefully it works with no problem, so we don't have to go for the nickel one. So let's draw here on the 8, and let's say I would say let's make it from here, 4 points from the middle, 1, 2, 3, 4. I just go again because we need to have some layer. We don't need to have empty spaces in the middle of the layer. Okay, so hopefully we have a good line here. And let's have, this one was 1, 2, 3, 4, it's 5, the 6th one. So let's have the same here. From the middle, 1, 2, 3, 4, 5, 6. So the 6th one from this side. And from here to here. You can draw any shape, you can do a circle, point, anything that you would like to do. But for today, I'm going to do with this slab with 2 lines, 2 conductive lines. So I've used this one, it's done. So I might need just to increase the thickness of the silver layer. Then we have to wait for 3 to 4 minutes to dry, but usually the longer the duration, the better the conductivity. So I have done it. Let's close it as I like this one, and let's wait for it's dried. Hopefully it dry fast. And while it dries, we'll fix it on the corkboard. And as we said, we have the metal mixer. Let's put it aside. This one here, and there, and this one. And we have here the multimeter. I hope you see the numbers. I will make it on the DC voltage. Oh, sorry. Let's make it, let's make it on the DC voltage. For now, I hope you see everything. So for now, hopefully it dries. Let's see actually how much resistance between these two. Okay, very good. 0.8 ohms. Good lines. Oh, this is high. 31 ohms. It's fine, still fine. Okay, compared to 90 kilo ohms. But to confirm that the lines are good, we have to basically connect two of these push pin ones to here. And let's put another one here. And from here we need to apply some voltage. We will turn on the power supply. We will make the power supply on 10 volt. Then we will let's make this one the positive side of the power supply, and this one the negative. So this is the ground, this is the positive, and the potential difference is 10 volts. So you can see here, if we turn this one to the voltage, you can see here that the potential difference is almost 10 volt. Let's make it here, the black one on the ground and the red one on the red one. So it's a 10 volt. And now to examine whether this line is good or not, the conductive line, we will put here this probe on the metal pin, and we need to see the difference, the voltage difference between the two probes along the line. And this should be around like 2% of the input voltage. So the input voltage is 10 volt, so we need to have like 2% maximum of 2 volt, which basically around 0.1 or 0.2 volts. You see here, the voltage difference is very small, very small, very small. So it's almost perfect conduction here. So let's see here. Very good, very good, very good. See if we put something here. Oh, the voltage difference is big. So right now the two conductive lines are good to go, and we can start basically finding the equipotential lines.